Welcome to Spring LIB.
So let's denote with BK the debt at the month K. So the following month, the debt will be the debt of the previous month plus the interest, so R divided by 12 BK, minus the payment that we made. Let's collect the BK, so 1 plus R divided by 12 BK minus the payment. Now let's write the first few terms. So B1 is alpha B0 minus P, where alpha I've just written to shorten the notation 1 plus R divided by 12. It's just a number because R is given as well. Now B2 is again alpha B1 minus P, and we replace B1 for the first line, and we get alpha B1 minus alpha P minus P. Then B3, we have alpha B2 minus P, which turns out to be alpha squared B0 minus alpha squared P minus alpha P minus P. So we see that the first term, the term with the B0, is just a power of alpha. And then we have the sum of powers of alpha with a P in front. So we can write this sum as minus P. And then we have the sum from 0 to n minus 1 of AI. Because, I mean, if n is 3, we're summing from the 0th power to the 2nd power. And we have a closed formula for this sum because this is minus P. And then we have alpha to the following power, which is n, minus 1, divided by the base minus 1. Okay, so knowing that, we can write the debt at the month K as B0 times the power of alpha, so alpha K B0, minus the term we've just computed, which is alpha to the K minus 1 divided by alpha minus 1 P. But again, we remember alpha is just a constant, is 1 plus R divided by 12. Now let's say that we want to pay our debt in time t. So that means that b at t, so the debt at the month t must be lower or equal than 0, which means that we've repaid all our debt. We can write this inequality from the first formula up there as alpha t minus 1 alpha minus 1 p greater or equal than alpha t b0. Now we want to know how big the payment p must be to repay our debt in time t. Therefore, p must be greater or equal than alpha minus 1 alpha t minus 1 that multiplies alpha t b0.